Good morning, everyone. So today, as a part of our course, Fundamentals of Soil Science, we are going to learn about soil profile. So before learning about soil profile, we need to understand what are horizons and what is meant by a pedon, what is meant by polypedon. And so in this lecture, we are also going to cover about what is the description we are going to do to describe soil horizons, soil profile, and what is the difference between surface soil, subsoil. And we are also going to learn about soil structure and how the structure is classified based on different aspects. So first, let me tell you what is meant by a soil profile. So soil profile is nothing but it is the vertical section of soil which depicts all the horizons, and it extends from the surface of the soil to the underlying parent material which lies far beneath the surface. So when you see this image, the bottommost one is bedrock and all the layers lying above it are horizons, and the topmost one is surface soil. So the soil profile extends from the surface soil to bedrock. So let us understand what are meant by horizons. Horizons are nothing but they are the horizontal layers which are parallel to the surface, and they have distinct and uniform characters. That means each horizon is having similar characters on its own, and it varies with the layers or horizons lying above and below it. So it is so as you see this image, each horizon is having uniform color, uniform density, uniform organic matter accumulation, colloids, hardness, structure, and texture. And it is varying with the horizons which are lying above and below it. So all these are called as horizons. Soil profile is nothing but it depicts all the, when we take the vertical section of soil from top to bottom, it depicts all these horizons which are lying one below the other. So next one is what is meant by a pedon. Pedon is nothing but it is considered as the smallest volume of soil which contains all the soil horizons. So it's generally having surface area of 10.76 square feet or approximately 1 square meter. So it extends from ground surface down to bedrock. So it represents it in simple terms, we can say it as miniature soil. So it is nothing but three-dimensional body. So here you are expected to have like blanks like what is the smallest unit of soil or smallest volume of soil is known as. So you should write it as pedon. So next one is polypedon. So now it is nothing but it is the combination of number of pedons. So when you see this image, there are three polypedons in this image. One is polypedon A, polypedon B, and polypedon C. So each polypedon contains number of pedons in it. So and all these polypedons together form one landscape or one unit of soil. Now you got it. What is meant by pedon? What is meant by polypedon? And then what is meant by horizon, what is meant by soil profile. All these terms we should understand first. Now we will go in depth. So all these horizons, when we take the vertical section of soil, different horizons will be visible to us. All these horizons are divided into two types. They are nothing but master horizons and subordinate horizons. First one is master horizons. Master horizons are nothing but those horizons which are formed from the soil forming factors. There are five soil forming factors according to Jenny, like climate, organisms, relief, parent material, and topography. So all these five factors act on them, and their interaction effects will act on them and lead to the formation of master horizons. So these master horizons are present in all types of soil. So they are designated by English capital letters. So generally there are a hypothetical or ideal soil profile contains generally six master horizons which are denoted by O, capital A, capital E, capital B, capital C, and capital R. So all these are called as master horizons. Then coming to subordinate horizons are not present in all soils. They are defined or confined to only one particular location. So they are formed due to the climatic conditions persisting there, and the local conditions or the chemical reactions occurring in that particular location. They are not present in all types of soils. So they are called as subordinate horizons. Master horizons are depicted by capital letters, whereas subordinate horizons are depicted by small alphabets. Okay. So now got it what are master horizons and what are subordinate horizons. So now we will try to understand what is the importance of learning this soil profile. So why we have to learn this soil profile? So generally, we should learn the soil profile because it is useful in surveys. It serves as typical example for soil mapping and also one of its components. And it is also useful for research purpose, which serves as a base record which serves as a baseline record to illustrate the environmental setting and relationships between the soil attributes. And it is also useful for land resource development, which serves as base for building georeference land information systems. So generally, we will study soil profile in order to classify or in order to map soils, in order to identify certain types of horizons, in order to identify certain types of soils. So that is why we have to learn the soil profile. What are the characters of horizons? So generally, all the characters of horizons are mainly divided into two categories. One are inherent characters and the other are acquired characters. Inherent characters are nothing but those characters which are inherited from the parent material. They are geological in nature. That means, example, the minerals which they contain, they are not acquired by their own. They are just carried from their parent material to them, like example quartz, mica, feldspar, whichever the mineral is abundant, that is generally the carry forward of their parent material itself. Then coming to acquired characters are developed by them due to the climatic conditions in which they are developed, due to the local conditions which are occurring, and due to the processes which are involved in the soil formation. For example, elevation and illuviation. So similarly, like humans also, inherent characters means the genetic characters which we acquire from the parents. Acquired characters are nothing but which we acquire due to the societal conditions, peer relations and all. So that similarly it applies to these horizons also. So how do we describe one horizon? So what are the different components we use for description of soil horizons? First one is we should describe it based on its designation and dimensions, then based on its soil color, then primary constituents, then organization of these constituents, then porosity, concentrations of various minerals, elements, whatever it may be, then biological activity, soil reaction, and samples. So I am providing you one image where this is one of the research work of our means our colleagues. So here how they have described this one pedon or one horizon has been given. So first they should mention about the latitude, longitude of that location, and what are the cropping systems, existing cropping system and previous cropping system, and what is the depth of each particular horizon, what is the color, what is the texture, structure, everything they has to maintain. So these are the sheets which are used for describing the oil horizons. So, each one how to designate, how to describe, we will see in detail. Firstly, designation and dimension. So each horizon will have one symbol. As I said earlier, master horizons will be represented by capital letters, whereas subordinate horizons will be represented by small alphabet. So if suppose the that particular horizon is having different horizons, like that particular profile is having different horizons like A, E, B, C, R, you should denote it with their capital letters. If they're having any particular subordinate horizons, then you have to write that particular small alphabet immediately after the capital letter. Suppose if in horizon A, if there is high amount of disturbance or high ploughing is occurring, then you should write it as capital A followed by small p. Okay, then if suppose in capital B horizon or in subsoil, it is also known as subsoil. In capital B, if there is abundant accumulation of clay, then B followed by small t. Or if there are presence of slick and slides, then you should write it as B followed by small s. So first letter, which is capital letter, includes denotes the master horizon, and the letter which is following this capital letter denotes the subordinate horizon. Then coming to horizon boundary. Boundary is nothing but the horizon, how deep is that and how distinct is that and what is the topography of that horizon can be given. And then coming to see like this, it can be designated A, E, B, C and all. Then, based on soil color, how do you distinguish? So, soil color has three different components. One is hue, value, and chroma. Hue is nothing but which is the dominant spectral color. Value is nothing but lightness or darkness of that color. Then chroma is nothing but purity of the color. So these three can be indicated both in dry condition and moist condition according to the Munsell soil color charts or any other standard soil color charts can be used for describing all these three. These three values can be given both under dry conditions as well as moist conditions. Then coming to modeling. So what is the abundance, size, contrast, boundary and color can be given under dry and moist conditions. Then based on the primary constituents are nothing but sand, silt and clay. So their proportion is nothing but texture. So how the texture, what is the texture of that particular horizon? Is it sandy, loamy sand, sandy, loam? There are 12 textural classes. So based on the texture of that particular horizon, we can give the information. Then coming to rock fragments, gravel, stones and boulders, their percentages can also be mentioned. All these comes under primary constituents. Then how they are arranged? The arrangement of these constituents is nothing but soil structure. So soil structure based on type or size and grade can also be mentioned. Then consistency. Which consistency is present? Is it wet consistency, dry consistency, or moist consistency? Can also be given. Okay. Then coming to voids or porosity, which type of voids are present? Like macropores are present in abundant or micropores are present in abundant. Then how what is the proportion or percentage and how the continuity of the pores is present? Then what is the orientation? All these can be given. Then concentration of certain things like cutaneous features. Cutaneous means nothing but the word cutaneous means like skin. It is not, it serves as the skin. How the clay, humus, pressure faces, lichen slides and iron coatings are concentrated can also be mentioned. Then cementation and compaction, continuity, structure, nature and degree can be given. Then mineral nodules. Then soil reaction. Soil reaction means nothing but it is the presence of carbonates or pH. Presence of carbonates means non-calcareous, is it slightly calcareous, moderately calcareous, all these can be mentioned. Then field pH means how much pH is present in that particular horizon can be given. So, so this is how we describe a soil horizon or a soil profile or pedon, whatever it may be. All these are the components or constituents which are used for the description of soil horizons. Now we will learn about the characteristics of master horizons and subordinate horizons. So first and topmost layer is O horizon. O horizon means organic horizon. So this horizon is generally absent in cultivated soils. Very important blank. So it is only present in undisturbed soils or virgin soils or forest soils only. Okay. Why is it absent means organic horizons means it is completely filled with organic matter. So its characteristic is accumulation of organic matter. Either it may be non-decomposed, decomposed or partially decomposed organic matter. So in cultivated soils, due to continuous soil disturbance, the organic matter is lost, with the top layer is lost. So the soil profile starts from A horizon in cultivated soils. So due to the accumulation of high amount of organic matter, it is very darker in color, and this layer is seen as top layer only in undisturbed soils and forest soils, as I said. So you can see the image also. This is the top layer and how dark is it? You can observe here. Then coming to A horizon, A horizon is also known as topsoil, very important blank. A horizon is called as topsoil. It is the topmost horizon in the cultivated mineral soils. So this layer is darker in color due to it is also having organic matter accumulation, so it appears darker. It is also characterized by high amount of plant available nutrients and also high amount of root distribution occurs in this horizon. You can see in this picture also. So O horizon, then followed by A horizon in forest and undisturbed soils, whereas only in our cultivated soil, it starts only with the top layer is A horizon. Then coming to B horizon, you can, sorry, E horizon. E horizon is nothing but it is a third top layer. This layer is characterized by elevation process. Very, very important. So elevation is nothing but washing out. What will be washed out? Washing out of aluminum oxides, iron oxides, and clay will occur in this layer, and it will wash out from that layer and it will be accumulated in the bottom layer. So due to washing out of all these, it will appear very pale in color. As you can see in this image here, so the E horizon is pale compared to the top and bottom horizons underlying it. So next one is B horizon. B horizon is the layer which lies next to E horizon. This B horizon is also called as subsoil. So it is characterized by hard pan, and it is characterized by elevation process. So whatever is washed out from E horizon will accumulate in B horizon. That means accumulation of sesquioxides and accumulation of clay is the characteristic feature of B horizon. 3 points you should keep in mind. B horizon is also called as subsoil, zone of elevation, and it is characterized by washing in of clay, organic matter, and sesquioxide. Then coming to C horizon. C horizon is nothing but it is the other name of parent material. So there bedrock is present. So when bedrock is undergoes weathering process, so unconsolidated and partially weathered product will lie on this bedrock. This unconsolidated and partially weathered product is known as C horizon. It is also known as parent material. So you can see here, especially under arid and semi-arid region, the C horizon will appear light in color due to the presence of lime and gypsum. So here you can see how the sea horizon in normal soils and how is it in arid regions, arid and semi-arid regions. Then coming to the R horizon. R horizon is nothing but bedrock. It is the bottommost layer of the soil profile. So this R horizon is characterized by consolidated hard parent material. Okay. So here some points you have to remember. So the sequence of the horizons is very important. O, A, E, B, and C. So all these together is known as soil profile. A plus B plus C horizons is known as regolith. Only A plus B horizons without C horizon is known as solemn. Okay, and the layers which are lying. So you can see in this image here, between O and A horizon, there is a transitional layer. It can be represented by capital O and capital A, followed by capital A. Then in between A and E horizon, there is again one transition layer. It can be represented by capital A and capital E. Then in between E and B also, one transition layer is there. That is known as E, capital B. Then between B and C also one transition layer is there, which is depicted by BC. Then between CR also CR. So like that, all the transitional layers which are lying between the horizons will be represented by two capital letters, whereas the subordinate layers which are present within the master horizons is represented by one capital letter and one small letter. We will see in the coming slides. So, subordinate horizon characters, as I said earlier, subordinate horizons are nothing but those horizons which are confined only to one particular location due to the presence of that particular climatic conditions and that particular chemical reactions or accumulations, whatever are occurring there. So there are number of subordinate horizons. So each subordinate horizon is depicted by small letter. So here, small n represents the accumulation of sodium. Then small o represents the residual accumulation of sesquioxides. Then small p represents plowing or other any other soil disturbances. Then small q represents accumulation of silica. Small r represents strong reduction. Small s represents alluvial accumulation of sesquioxides. Small t represents accumulation of clay. Small c represents concretion or nodules. Then small f represents frozen soil. Small g represents glaying evidenced by mottling. Small h represents accumulation of soil organic matter. Then small j represents jarosite mottling. Jarosite mottling is nothing but sulfur accumulation which gives yellow color mottled appearance. So small k represents accumulation of carbonate. Small m represents cementation or induration. Then small v represents plinthite layer. Then small w represents color, development of color or structure. Small x is fragipan character. Small y accumulation of gypsum, and small z is the accumulation of salts which are more soluble than gypsum. So all these are used for characterizing the horizons. So you can see here one example of a soil profile of black soil. Here they have given capital A and small p. Capital A is nothing but top soil layer, and small is p indicates the plowing or soil disturbances which are occurring. So how is it depicted? You can see here. Then capital B, this is nothing but subsoil. It is followed by smallest. That means they are telling us that in subsoil there is abundance of slippery slide presence. Then capital B and capital C is nothing but it is the transitional layer between B horizon and C horizon. So similar, one more example for red soil also. So this is how the soil profile can be dug and how the soil profile studies can be made. And here on the right side, if you see the image, this is called as monolith. Monolith. So now we will see the differences between surface soil and subsoil. So surface soil is nothing but it is the completely weathered material. So as it is completely weathered, it is loose and friable and it is highly porous in nature. It has final soil particles like silicate clays. It has good aeration, and due to her presence of high organic matter, it is darker in color, and it has high microbial activity, and it is highly fertile. There is no hard pan occurrence here, and good physical condition and also high CEC. Whereas subsoil, if you see, it is partially weathered. It is dominated by coarser particles like quartz. Then it is massive and compact, and it has poor aeration, and the number of microbial activity is low. Number and microbial activity is low, and the organic matter is low. Then it is lighter in color, and the fertility is also low compared to surface soil, and it has hard soil pan, and then poor physical condition and low CEC. So all these are the, this is very important question for your exam point of view. So till now we have learned about soil profile, master horizons, subordinate horizons, and differences between surface soil and subsoil. Now we will see what are different components of soil. So if you take a handful of soil or 100 grams of soil, every soil has three phases in it. One is solid phase, second is liquid phase, third is gaseous phase. So when you take the solid space, the solid space will be 50% and the pore space will be 50%. So solid space includes mineral matter and organic matter. So this 50% can be further divided into 45% of mineral matter and 5% of organic matter, whereas pore space has two components in it, that is soil air and soil water. So if we take any ideal soil conditions, this any ideal soil will contain 25% of soil air and 25% of soil water in it. So if suppose if you are asked to write about the soil components, then you should describe the different phases of soil. Then you should write what is the percentage distribution of solid space and pore space. Then again, how further pore space is divided. So you should also depict it with the help of this diagram. So with this, we have completed the soil profile and components of soil. Now we will learn about soil structure. Before learning about soil structure, in earlier classes, we have learned about what are the primary constituents of soil like sand, silt, and clay. So their proportion is known as soil texture. So their arrangement, the how the sand, silt, and clay fractions are arranged, their arrangement is known as structure. So to learn about soil structure, we need to learn about two important terms. One is bed and one is clod. So arrangement of primary constituents into aggregates is known as soil structure. So if these aggregates are naturally formed, then it is known as bed. If these structures are, if these aggregates are artificially formed, that means with the help of any tillage instruments or due to any physical manipulation of soil, if they are artificially formed, then it is known as clod. Very important for blanks purpose. So here you can see the first one is natural aggregate and the bottom image is clod. So here this slide shows the definition of soil structure. That means Arrangement of primary constituents into aggregates is known as soil structure. So soil structure is very important physical property which changes with physical manipulation of soil. So this soil structure influences many other physical properties like water retention, movement, and availability. It also dictates some properties like heat transfer and hydraulic conductivity, then soil aeration, then bulk density, then soil porosity, and also chemical properties like nutrient availability, retention, nutrient movement, and other nutrient transformation. All these are the important processes which are governed by soil structure. So here you see in this image these are the primary particles or primary constituents. Clay particles, sand and silt particles are present. All these particles are arranged together to form a group. That group of them is known as soil aggregate. So these all are joined by different cementing agents like clay, organic matter, or iron and aluminum oxides. All these serves as cementing agents. So all these cementing agents will join these primary constituents to form an aggregate. So we will see how the structure is classified based on different aspects. Excuse me. So how the structure is classified based on different aspects. So firstly, soil structure is classified mainly on three attributes. First one is shape of the aggregates or beds. Then second one is size of the aggregates or beds, and third one is distinctness and durability of the beds. So the shape is given by shape of the aggregates is given by type, then size by class, and grade by grade gives the distinctness and durability. So now first we will see how the soil structure is classified based on the shape. So we will see there are mainly four structures, four types of soil structure based on the shape. First one is spheroidal structure. Second one is block-like structure. Third one is plate-like structure. Fourth one is prism-like structure. So you can see different images here. So we will see them in detail. So first one is spear-like structure or spheroidal structure. In this structure, the each aggregate is in the form of or is in the shape of a spear. So this is nothing but single grained structure. So this spear-like structure is further classified into two types. One is granular structure and other one is crumbly structure. So granular structure is nothing but here the porosity will be less, whereas the crumbly structure will have high amount of porosity in its aggregates. So this spear like structure is highly suitable for agriculture, and among these spear like structures also crumbly structure or crumb like structure is the best suitable structure for agriculture purposes due to the presence of good amount of pore space or porosity. So that is very important one. Crumbly structure is best suitable for agriculture. Then second one is plate-like structure. So this plate-like structure is nothing but here the horizontal axis of the aggregates is larger compared to the vertical axis. It resembles like a plate. So this plate-like structure is here the alignment is horizontal, and here it is mainly occurs in E horizon. So this plate-like structure is also further divided into two structures. One is platy and second one is laminar. Platy means the thickness will be more, whereas laminar means the thickness of the each aggregate will be low. So this plate-like structure is worst structure, means it is not at all suitable for agriculture because it hinders the infiltration, it hinders the root penetration, it hinders the seedling emergence. All these processes will be affected due to this structure. So that's why it is not suitable for agriculture purpose. Then third one is block-like structure. Here in block-like structure, the horizontal and vertical axis will be almost equal. So it leads to the shape of a block or cube. So here they are not independent, but they are associated beds and their size varies from 5 to 50 millimeters. Then the subclasses of this are subangular blocky and blocky. So these subclasses are mainly due to the edges, their shape of the edges. If suppose the edges of this individual aggregate are sharp, then they are angular blocky. If the edges are rounded or smooth, then it is subangular blocky. So this structure is mainly seen in B horizon, and this structure facilitate good aeration, good porosity, and good drainage also. Then coming to the third structure, which is nothing but prism-like structure. So prism-like structure is nothing but here the vertical axis will be longer compared to the horizontal axis. So it gives a long shape, vertical shape. So this structure is commonly seen in the subsurface layers and sodium dominated soils, and it is prominent in swelling type of clays. So in this structure also there are two subclasses. One is prismatic structure, second one is columnar structure. Columnar means if the edges are rounded, then it is columnar. If the edges are sharp, then it is prismatic. So here in this image, this is columnar. So this is the table showing different soil structure along with the images. Here platy, then prismatic, here columnar, then this is the granular structure, this is blocky, and this is wedge shaped structure. So as you can observe here, the classification is mainly based on the length of their axis. Means how the horizontal and vertical axis are, the length is varying. Based on that only, they have classified. The second classification is based on the size of the aggregates. So as I said earlier, these four structures are again further divided based on the size of their aggregates. There are five classes: very fine, fine, medium, coarse, and very, very coarse. So the dimensions or their length will vary from each type of the structure. You can see here. For granular structure, very fine means less than 1 mm, whereas for angular blocky and block-like structure, it is less than 5 mm. Here fine means 1 to 2 mm, here fine means 5 to 10. So like that it varies. Here medium means 2 to 5, here 10 to 20 mm. Then coarse means 5 to 10, here 20 to 50 mm. Similarly, for plate structure, very thin means less than 1, thin means 1 to 2, medium means 2 to 5 mm, then thick means 5 to 10 mm, and very thick means greater than 10 mm. So here for prism-like structure also, very fine means less than 10 mm diameter. Then fine means 10 to 20 mm. Then medium means 20 to 50 mm. Then coarse means 50 to 100 mm. Very coarse means 100 to 500 mm. Then extremely coarse means greater than 500 mm diameter. So here, in if you can write in exam like this. So here you can see very clearly it is given. So for platy, what is very fine? For prismatic, very fine means what? Columnar, very fine means what? Like that, this table you can represent while writing in exam. It is given by soil survey staff in the year 1951. Okay. So now third classification is based on the distinctness or durability. Distinctness or durability means strength. So if you take the aggregates, how durable they are, how strong they are, or how distinct they are. So here there are two types, structureless or massive. So structureless means they are very weak, very weak. That means they are present in the form of loose grains. Okay, their strength is almost zero. So they are called as structureless soils. Structureless soils means mainly alkali soils or sodic soils. So that too, when they are in dry conditions, they are structureless in nature. Then coming to the weak structure. Weak structure means the coherence or the strength is very weak, poor, and non-durable. It can be broken into small pieces very easily. Okay. Then second one is moderate. Moderate means fairly durable pets, and they are distinct and they are somewhat well developed. Whereas strong structure means strong coherence will be there, and they are durable and they are distinct also. That means they are very strong in nature. They cannot be broken very easily. So so grade of the structure means you will write grade of the structure will be differentiated into two types, structureless and massive. Structureless means nothing but sodic soils. That means they are usually loose grains. They do not have any proper structure. Then massive means in that again three categories. One is weak structure, moderate, and strong. Okay, so this is the classification of soil structure, very important. If you are asked to write about soil structure, you should write about definition, then you should write about their classification in the form of flowchart. Then while explaining each like type, size, everything, you should be representing along with the diagrams for sure. One more important thing what we should learn is we should also understand the importance of soil structure. As I said earlier, this soil structure dictates many other physical properties like bulk density, porosity. Okay, each one you have to explain in detail. Suppose porosity is there. If the structure is if there is platy structure, porosity will be less. If the structure is crumbly, the porosity will be more. Similarly, bulk density of platy structure is more compared to spheroidal structure. Okay. Then coming to water retention. Water retention is more for spheroidal structure compared to platy and other structures. Like that, you need to write the importance of soil structure. Then again, you should also understand how the structure and texture will be differing. That means the difference between soil structure and soil texture. Soil, first you will write the definition. Soil structure is nothing but it is the arrangement of soil physical primary constituent, that is like sand, silt, and clay, how they are arranged. And soil texture means it is the relative proportion of sand, silt, and clay. Then soil structure is not the basic property, whereas texture is the basic property because it cannot be altered by any physical manipulation. Soil structure can be altered by any physical manipulation. Then what are the properties governed by soil structure, influenced by soil structure, whereas what are the different physical properties which are influenced by texture? Then soil structure, then different forms of soil structure can be written, and different textural classes can also be written. So this is how you will write the differences between soil structure and texture. So that's all for today's class. Thank you.